Okay, let's start. And my name is Michael Staib. I'm a GraphQL technical steering committee member, and I'm also the author of the Hot Chocolate GraphQL library in .NET. Today I want to talk about building modern applications with GraphQL, and we will use the newest bits of GraphQL, so the things that will come out with the next spec release, and also the newest bits that we have for .NET 7. So before we get started, let's make a quick quiz to see how everybody is on GraphQL. So take your smartphones and join me. Awesome. So first thing, have you used GraphQL before? Have you used it in production? Or you just experimented with it? Or you have no idea and you just came to look what GraphQL is? Okay, that's a very typical graph for .NET. So in .NET we are a bit more conservative. That's why a lot of people are more, I heard about it, but I have actually not the right idea about it. And maybe I experimented with it. But like, there's a lot of people who don't run GraphQL in their day-to-day business. So how old do you think is GraphQL? Okay. So a lot of people think it's 10 years, and the other bucket is more around 5 years. Let's have a look. So actually in 2012 was the year when Facebook used GraphQL in production. So they started actually developing it earlier, but 2012 was when they merged it into production. And actually back then they called it Supergraph, for lack of a better name. And they renamed it in GraphQL, which was not the best name because many people think it's a graph database query language. So, yeah, almost. I have to update my slides, actually. Okay, so what is GraphQL? And to answer that, we have to actually look at why is GraphQL? Why did Facebook create GraphQL? And it has all to do with mobile applications. So there is the general assumption that GraphQL is a JavaScript thing because it is so popular in the in the JavaScript ecosystem. But actually, it was developed for native mobile applications. Back then, Facebook had a big problem with their mobile applications because people were complaining about that their devices get really hot, they have slow startup times, their battery draining a lot. And Facebook really had pressure back then. People thought that Facebook cannot do the drift to mobile applications. And there was talk about Facebook not surviving that age. As we now know, they survived it. By the way, this was actually a Facebook app, much uglier than the new one. And this was the newsfeed back then. So the main issue that the Facebook engineers discovered when they looked into the problem of their mobile application was actually that they used REST as a backend technology. So to say that it's wrong to use REST is actually also wrong. it was more what they used in their normal website for Facebook. So they were using HTML to render their UIs in the mobile application, so they essentially built a wrapper. And they used REST to communicate with the backend. But they used the REST API for their desktop application. So when they opened the application, basically the first call was to fetch the user. And they got data for that. They actually needed 3 properties, but this request returned 50. And it was not just one call, it was actually a couple of calls. And they first fetched the current user, then they fetched the news story for that user. Again, they just needed a couple stories because they didn't have even so much screen space. But they, again, got more than 60 properties in that request. But the news story is not enough because you also have comments. So you would collect all these IDs that you had from the previous request and feed them into another request to get the comments. And again, you just need a couple of properties there. And you would collect, again, a couple of IDs here, and then maybe fetch the profile picture of the users that made comments. And this is not efficient. It would look something like this if you looked at the developer tools of Chrome. This is faked, but just to give you an idea, we call that a data waterfall, where each consecutive request is dependent on the previous request. So essentially, we are doing data aggregation on the client side, which is really, really inefficient. So what they discovered is that their mobile application actually has very different needs from their desktop application or their website that was made for the desktop. At that time, Facebook was not alone. Actually, there were a couple of companies like Netflix who invested in solutions for this very problem because they had applications running on game consoles, on mobile applications, on desktop applications. So they were trying to solve that also in their way. They called that the Netflix client-optimized adapter, which was kind of what GraphQL was aiming at. There are also other patterns like the BFF pattern, but if you think about Netflix, if they really built a BFF for each of their applications that they deliver, for the Xbox console, for the mobile applications, they would be very busy maintaining these. So this is where GraphQL came in, and the moment Facebook released it, all these companies that were doing experiments in this space were actually rallying behind GraphQL. So this is a GraphQL query. It fetches the currently signed in user, and from that user, just the name. If you send that to our GraphQL server, we actually get a response that closely aligns to our request. It almost looks like we are filling up our empty JSON graph here. It's not like that, actually, but it's a good mental picture to start thinking about GraphQL. But as our use cases change, or we build new experiences or new clients, we can just change our request, ask for more or less data from the backend. And the GraphQL server will fulfill that. But when we look at this GraphQL query here, we can see it's not about sparse fields. It's actually about trees of data. So that is why GraphQL is so great with relations. We can drill into data. For instance, fetch in one go not only the currently signed in user, but also the news stories or the friends of this user. There's one more concept in GraphQL, and we call it a fragment. And that is aimed at the front-end developers. So a fragment is our data contract for our UI component, you could say. You can bake that into your GraphQL query. And the great thing here is, if we look, for instance, at a React UI component here, we can see that we can co-locate our data needs, our data contract, in our React component. The same works with Blazor, for instance. We can do that in the same way. And then we have, like in our component, the data we need and the data usage. And the second cool thing is, as I compose my components, I'm actually composing my GraphQL request. So GraphQL gives clients or consumers of our API the power to ask for exactly what they want and nothing more. And that is giving you super fast backends and super reactive frontends. So what is GraphQL? GraphQL is the query language for your API and a runtime to fulfill these queries. So with GraphQL, we just have one endpoint because we don't need all these endpoints that we had with REST API because we are defining a query and then we send that to that endpoint. And that means we can fetch all the data we need at a specific moment in time for our user experience that we want to build in one request. There's no over or under fetching on the client. And when we looked at the request earlier, you saw all these data aggregations on the client side. That is super inefficient. Now we can aggregate the data in the backend where we are close to the database or close to our microservices, and we have zero latency. And GraphQL is built on a strong type system, and that is super important. And we will look at these aspects in a couple of demos, because these gives guarantees to the client side. You could say there's something like this, the Open API specification, for instance, but it's not baked into a runtime. We are just, with the Open API spec for REST, we are just saying, okay, this is my type system on the backend. But there's nothing enforcing this. So if you violate one of these types, there's nothing stopping these data violations getting through the client. So the client always has to check. With GraphQL, that's not the case. And that makes it super predictable to use. On top of this, GraphQL is real time. Before we look at some code, so there are 3 GraphQL operations that we know of. There's read operations. This is our GraphQL queries. It's the get in REST. Then we have write operations. These are our mutations in GraphQL, and the put, post, patch, delete in REST. Lastly, we have in GraphQL events, and we call them subscriptions. Okay, let's have a look at some code. So this is my first demo, and we will dive into how to build a small GraphQL server. Let's get rid of this guy here. So how do we build a GraphQL server? And that is quite simple. We just do a .NET new web, and that is an ASP.NET Core web application. And if we look at that web application, it's basically the minimal API we expect, right? Okay. To make it a GraphQL server, we need to add a package here. And I'm adding here the Hot Chocolate ASP.NET Core package. And then let's quickly restore it. And then we have all the ingredients to build a GraphQL web server. So the first thing, we talked about the operation types. And there is this query operation type, and that's the first thing we want to build. So I'm going to create here a class, a simple class called query, and that's my root operation type. And the next thing, let's start with a hello world here. So I'm adding a little method here called hello. It has an argument name, which has a default world. And then we just concat here a string and return the result. And that is a valid GraphQL root type. Next, we're going to set up our GraphQL server. So I'm adding here a couple of services. And in my service collection, I'm adding the GraphQL server here. And then I'm registering our query root type. Awesome. So there's one thing left, and that is the transport. So I need to map the GraphQL transport here. Let's do that. So I'm just saying here, map GraphQL, and then I'm done. That is my GraphQL server. Let's run it. Actually, let me do a no hot reload, because sometimes it messes up. Okay, So this is my GraphQL server. It gives me a 404 because GraphQL by default is on the GraphQL route. And if I open that up, I'm greeted here by our GraphQL IDE, Banana Cake Pop. It's also done by our project. Let me zoom that in. Okay. The coolest feature is actually that we can take off the glasses, but okay. Now let's explore our GraphQL server. So this is basically a new tab, and I can explore my API with that. I can go here to the schema reference, and you can see now I have a query root type here. And my query root type has a field hello, which returns a non-nullable string. In GraphQL, we have non-nullability. And you can see even my default value translated into GraphQL. So that is awesome. We can now query that. So let's write a GraphQL query. I'm querying here my field hello. If I run that, I get what I expect. But in GraphQL, fields are more like methods. So I can also pass in here the name argument. So I can say Michael, run that, and I get hello Michael. So that looks easy. So let's put a proper object structure into that. So let's create maybe a simple book field here, or a book type. And a book has the author, so let's also create the author here. And then let's just create a simple method here to fetch the authors. So get books. Okay, let's go back to my GraphQL server. Let's refresh the schema. Go into our schema reference, and you can see we have here the books field. Because in GraphQL we don't have these verbs, and we apply these GraphQL best practices in naming on top. That's why it's called books here. Okay, and I can also now query that. And as you see, not only flat fields are easy to integrate, we actually inspect the whole graph or your whole object tree that you expose to GraphQL, and then you can query for it. And we can run that, and then we get the data. Okay, so that was the first piece of GraphQL experience that we now collected. This is our query type that we created. We call this piece a resolver in GraphQL because it resolves our data. And it translates to a GraphQL type that looks like this. The whole approach here is called the annotation-based approach, and that's the original GraphQL approach that Facebook started with. But their GraphQL server, the first GraphQL server, was written in Hack. It's compiled PHP. This C# type then translates into this SDL type, and it also infers correct all the pieces here. So our method, our resolver, becomes a hello field. And we also infer this argument, so our parameter from our C# message translates into an argument of our field. We have in GraphQL default values. We can even have more complex default values than in .NET. We can have full object structures here. And we also understand non-nullability and nullability. By default, a GraphQL type is nullable, and the exclamation mark makes it non-nullable. So it's reversed to C#, where we have the question mark to make something nullable. In GraphQL, we need to make something non-nullable. Okay, so GraphQL lets us model an interface to our core domain. Or we could say, GraphQL allows us to expose our business layer in a much richer way. Because the GraphQL type system has all these capabilities like interfaces, discriminate unions, and so much more. So I can model my business application, then infer from that the GraphQL schema, and then can access this over the wire suddenly and ask for the data I need for my application. So let's talk about transport here. So GraphQL is actually transport agnostic. But there is a GraphQL over HTTP spec, so we can communicate with GraphQL via HTTP post, HTTP get, or also other things, even gRPC, or if you wanted to do TCP sockets. Most used is HTTP post. That is the most used GraphQL transport, and we use that for queries or mutation. But for subscription real-time, we could also use WebSockets or server-side events. So this talk is called Modern Applications. Let's have a look at a modern application. And for that, let me, no, I got it here. That is actually my modern application. This demo was cooler a couple of months ago. It's about cryptocurrencies. The prices are not real, so there's no reason to sell. So this is a typical application that works for mobile, and I call it modern application because it really lives. You can see all the data is being updated in real time. And look here, for all this data I fetched here, it's one GraphQL request. And no matter what I do in this application, maybe I'm going here onto the Bitcoin, it's just one GraphQL request. And that makes it super efficient over any network technology. So if you're mobile or if you're on desktop, it's super efficient. And even if I'm now fetching here a bit more or different graph, like the weekly graph aggregation, it's just one request. And actually, GraphQL clients work together with client-side caching. That means if I go back, there's no GraphQL request. And we are not fetching all the data. We are just always fetching the difference that we need more, right? OK, so let's build or see how we can build for that the backend. So what do we want to reach with GraphQL? We want to have a faster iteration between front-end and backend, because we want to enable the front-end developer to not have to go to our backend engineer every time to get a specific optimized GraphQL or REST request. We actually want to give them a tool to tell us what they need for their components without us backend engineers needing to redeploy always our backend. We want to have static typing and always the most efficient way to fetch the data. On top of that, our application should be reactive, like you saw. So let's have a look at how we could build the backend for the application I showed you. And that is demo 2. So I'm using Entity Framework now for my demo here, but you can also use other technologies like MongoDB, RavenDB, Elastic, or whatever. It plugs just into hot chocolate. So in this instance, I have here the data, that's my asset, my cryptocurrencies, and I also have an object price here, right? And I want to make that fetchable through GraphQL. So we already learned that we need a query root type to fetch data. So I have here our query root type that we had before with the hello world field. So in order to fetch my assets, I'm going to introduce a new resolver here called getAssets. And this resolver gets injected here the asset context. So we have resolver level dependency injection. And we do that because this way the execution engine knows what your resolver needs as dependencies. And this is super efficient in how we resolve dependencies. The second thing is that I just do my data fetching here, and then I return a queryable. OK, so my resolver is done. And I need to register now my DB context here with my GraphQL configuration. We do that with Entity Framework to essentially accommodate the non-thread safety of the DB context. So what we will do here by default is inject a scoped container into the resolver. So you don't have, even when we parallelize data fetching in the execution engine, you always have the right container instance on which you can operate. OK, with that, we are actually ready for running our application here. Let me just do that. .NET watch hot reload. And then let's grab a new window and go to our GraphQL endpoint. Okay, so I already have here my types. This is my hello field, and there is my asset type. And if I drill into it, you can also see it also has the nested structures here. So it inferred my whole DB context here, and we have everything in that we need. So I can just go here and actually query my assets. Let's get the names, run that, and I get them, but it's a lot. So it's essentially all that I have in my table, and that's the right moment to talk about pagination. So when Facebook created GraphQL, they also rethought pagination. So they went away from the typical offset paging because they had the problem that there's always new news stories coming into their table. And that means when you page through their news stories, you had the cases that you got the same news story again because you just skipped and took the next data, but there could be now a ton of new entities there. So they came up with something that is called a cursor-based pagination or key-set pagination. And the idea here is that we navigate relatively from our entities. So we would not say skip take. Instead, we would say after this entity, give me the next 5. And this way, our pages move actually. So let's see how we can implement that with hot chocolate. Let me go back here into my demo. And then we write some code to get that integrated. So I'm going here to my query type, and then I'm saying use paging, and then we are done. It was more about the concept. And we actually can now query the whole thing. So I'm refreshing here. Now you can see my query is actually invalid because we have rewritten the types here. We have now an asset connection. And you can see we have a lot of arguments here, like first, after, last, before. And now I would go here for the nodes field. And you can see that I'm only getting now a couple here because we have a default page size. And to navigate that, I can grab the page info now. I can ask if this has a next page, and I also can ask for the end cursor. And if I do that, you can see here I have the end cursor, and that's the cursor of this element here. I can grab that and just feed that here in. I can say after this guy, I want the next 2. Okay, and that translates automatically because I returned here a queryable into my database query. Let's go a bit further with that. What if I wanted to have client-side query ability, so to filter or to sort my data set? So it works essentially the same way. I go here, I say use projections maybe to only select from the database what we actually ask for, then use filtering to filter what items I want to have from my data set, and also use sorting. These are data middlewares, and I need to register them. So I'm going here and register them. So now they are available everywhere in my schema, so I can use them. And let's refresh that here again. So the data structure is here the same, but you can see that I have now actually more arguments here. So I have a where argument and an order argument. And now I could go in here and say, I want to order my data set by the description, which is kind of stupid. And that's why you shouldn't just apply that on your data set or on your business layer or on your repositories. You actually should limit that to what is useful in your application. So what I'm going to do is edit that a bit. So we're going to introduce here another type. And this type will limit what we can sort, for instance. So I'm creating here a new input type. And that is an asset sorting input type here. And you can see I already added here the bind fields explicitly for my sort type. And then I can tell it what should be sortable. So in this case, everything that is navigatable from the price field. So all the subfields that I can reach here, that should be sortable. There's one more issue. At the moment, I have here the order by fixed, so we could only apply order structures on top of that. So I'm going to rewrite my resolver here a bit. And now I'm checking if the user provided an order here, then I'm not applying a default order. And with that, let's go back to our GraphQL IDE, refresh that. And if we look at our schema here, I can see that I can only sort certain things now. Wait, is it sort input? No, that didn't work. Sometimes sort reload messes up my demo. So let's just restart that. Okay. So let's refresh that and then write an order here. Now we have the price and only the price. And then we can actually sort that in ascending order. Order price. So we want the Bitcoin. We want Bitcoin first. So we are ordering by price in descending order. I'm running that. And actually, let me get rid of the paging here, because that is something we don't want. And then the Bitcoin should be first. But we could also have it in ascending order. And then I have something else there. And just to have a look at how this translates, you can see it perfectly translates into the SQL we want. You have only the data I selected, its name here, and we have here join with the asset price field, so it really nicely translated into SQL. Okay, let's go back to the slides and talk a bit about field middleware. So how does it work actually? So this guy is a resolver. And on top here, the use paging is actually a middleware. And these other things are also middlewares. And who knows the middleware pattern in ASP.NET Core? Okay, it's the same thing, but we apply it per resolver. So we build up a field pipeline here. And that means we have this pattern of next await. So we can, in each middleware, essentially defer to the next one in the pipeline and wait for the data to return, and then we can apply on top of the queryable like expression trees. And these expression trees can then be rewritten by the database provider into like the database query language. And that works not only with paging, it works also with filtering and sorting and whatever you have. So a GraphQL query like this could be translated into the perfect SQL version of that. But actually, that's not the best practice to just put your database under there. It can be cool if you want to do rapid development, but typically we don't have that. Facebook actually started with this, and that is actually where you should aim your work at. Having GraphQL on top of your business layer, and then you create a nice domain for your front-end developers to fetch data from. So, but when Facebook released GraphQL, people went more into that direction. They thought, oh, GraphQL, it's a great gateway technology. So let's not only have it for the data that I put in my GraphQL server, let's actually merge data from everywhere in our company in. And it tended to something like this, where I maybe have something like the data fetching I just wrote, but I also have other things where I maybe have aggregations in some Azure functions or whatever, and then I would merge that into one type system. So what we're going to do for our application is integrate this price change service that we have running on Azure, and Azure had an outage today, so let's see if that demo works. So we have a Azure function somewhere that lets us fetch for each asset an aggregated price change. This price change service gives us a response like that, where we get the aggregate percentage change, and we want to integrate that into our graph. But it not only works with REST, whatever you have there. Okay, so let's go to the next demo. Demo 3. So the first thing is, because REST is this thing that we don't have, I don't want to even generate types for it. So I can just type it statically here and create a schema.graphql. This, by the way, is the same service that we had before, a bit more advanced. We have now assets, we also have users and stuff like that in here. And we want to kind of merge now this REST service into our GraphQL server. So I'm creating here a schema.graphql, and what I can do is type the data, set the static typing for my GraphQL server. So I'm creating this SDL type here, and I say, okay, from the data that REST service had, I actually just want the percentage change, and that comes from a JSON object that I will have in my execution engine. Okay, so this guy, we need to register. This is our GraphQL configuration. You can see it has grown a bit, and we're going to add here the document that we just created. And then this type is now already part of our type system. So now we need to wire that up. So we kind of need to create a function in our price change object that we have, or our price object that we have. But I don't want to change actually my business layer or my data layer here. So in Hot Chocolate, we have kind of these extension types. So I can create a class here, and this extends our actual model with all the GraphQL specific stuff. So I don't have to bleed GraphQL specifics into my domain layer or into my data layer. And in this instance, I'm just adding here a method. It's called getChange, and it refers to the type in my document. So I'm saying here it's a getChange, it's a JSON that I'm fetching with the HTTP client, so very raw. And then I actually can use it. Let's just start it. Okay. Let's refresh that. Should not be. Oh, that's the wrong one. This one is better. Let's refresh the schema here. So it still works, same schema, but now I can do more. I can drill into my price. And actually, in my price, I have here a method or a field, a GraphQL field, and that is the function that we just added. So when I fetch here the price percentage, I'm actually fetching from a REST service here. Okay, let's fetch the hourly aggregation, and we do that. And actually, that is quite slow. You can see, and I can tell you why. Because we are now fetching for each item one REST call, and that is very inefficient. And Facebook also ran into these things, so they came up with a concept they call DataLoader. So what does a DataLoader do? When we fetch this change field, we are doing a REST request here. And we're doing a REST request 10 times now, and that is super inefficient. So they came up with something that they originally called preparable. But nowadays it's called DataLoader, and it allows us to batch request data. So how that works in a way that it's transparent to everything that we do is that the GraphQL resolver will, instead of doing the request itself, ask DataLoader. And the DataLoader has a task cache. And each time you ask a DataLoader, it will actually look into the task cache. Do I have for this key, for what you ask, actually a task to await on? If not, it will just issue a new task, and you can await that task. And that will actually lead to your execution engine at some point to deadlock. And that means your execution engine cannot do anything anymore because it's just awaiting everything. And at that point, the execution engine will dispatch the data fetching calls to this backend and get all the data in one call. But your REST service must be batchable for that. So my REST service allows me to send multiple things in. And if you have legacy infrastructure, it's actually easy to make it batchable. So that is where DataLoader come in. It also ensures consistency in your graph. If you fetch multiple times the same thing in your graph, it's actually always the same version because we have a request cache. So in the request, we are caching everything that you resolve, but as soon as the request is done, we clear the cache for that request. Okay, let's actually build that in quickly. So how do we rewrite that? So to introduce a data loader here, let me do that. I'm creating actually just another method. And I'm essentially copied this code down here and made it batchable. So I'm saying here, I'm accepting multiple symbols here, and I'm giving you back a map that tells you this key has this item. And then I'm doing here a bit the data call, aggregating the data, and now I can use that. So this is just a method. What we do in Hot Chocolate is actually using a source generator to generate you the actual data loader. So let's first update this piece of code. That is my resolver. And let me get the new one. And you can see the resolver actually became a lot easier because we just call now this data loader here. And you can see from this method, we actually generated you the more complex data loader code. So, and then you can just ask here for whatever data item you want to have. Let's just run that and have a look at that. And suddenly our data fetching is a lot more efficient. You can see it's done here, and I'm fetching here all the items in one go. You can see there. Okay, so this is how we made integrating external services efficient, and it feels just like GraphQL. Nobody knows that there are tons of microservices behind your GraphQL layer. Okay, let's talk about mutations. So far we just did querying data, but how about changing data? Because that is where GraphQL really shines for the front-end developer. So this is a GraphQL query. We are fetching data here, and the components of that is actually the blue thing, the keyword query, is the operation that we're going to use to execute the request on. Then we have the operation name. That is how we name it. It's up to us to name it. And then we can pass in variables into our query arguments. It kind of looks like a function. So in GraphQL, we are actually creating functions for your client. That is a GraphQL operation. So the next thing here is these guys we call selection sets. And this, essentially each selection set we can select data. And in a query, we have this root selection field here. That is our entry point. And this is a query. And in a GraphQL query, everything is a query. But when we think about mutations, only the top level field is a mutation. Everything beneath this top-level field is actually querying the change that you did to your system. And that allows me, for instance, to create a new thing and then select the impact that this had to your backend. Mutations on the top level are sequentially. So the way we execute that is first we would execute the first mutation, then we would execute in parallel all the subfields. Then the next mutation, again, query the subfields. And ideally, in this case, where we add and remove a thing, nothing would have happened at the end of this thing. Okay, let's have a look at how we can implement that. And then I show you a couple of cool things really with that. This demo. Okay. Let's just watch that already. Okay. Okay. So what we want to do here is actually add a mutation. And I already have here in my types created in the account an empty watch list mutation class. And what we want to add here is a mutation that allows us to create a watch list entry. So essentially put one of the bitcoins or whatever into our watch list. I already have here a repository. So far we just used Entity Framework directly, but in this case I'm using here the watch list repository, which has a method here, add asset to watch list. And what I already did here in the program CS, I registered my service as something for GraphQL. So GraphQL knows I don't have to annotate that in my functions. I can just use the watchlist repository. And it also knows how to deal with it. Since this watchlist repository has an asset context, so something of entity framework in it, we scope it per resolver. So again, we create an instance, run the resolver, and then dispose it, essentially. Okay. So let's go into our mutation, in our watchlist mutation class here, and add our mutation. Sorry. And this mutation essentially is quite clean. We add the symbol here. The symbol is what we want to add to our watch list. We have the username from our state, so that's defined in user. And also we have here the repository, and we can execute on that. This is a valid mutation. I can just run it. Let's just save it, go to our client, and let me see if I already wrote something here up. Yeah. So this is how a mutation structure could look like. I'm adding here something to my watch list. Let me refresh that. And if I run that, I actually get an error. Because my mutation has some preconditions in here. For instance, it throws, if there's no user signed in, it throws a not authenticated exception. And it also throws an exception if it doesn't know the asset that I'm trying to add here. So these are actually cool errors that I could have in my UI if I could understand them. So what we can do in our mutation is telling it what kind of errors are actually relevant to my UI developer. So I'm adding here the exceptions that are relevant to my user. And suddenly, I can refresh this thing. I could have a look at my mutations here. And then I can see, okay, it has errors. But it not only tells me what errors, that it has errors, but also what errors this method or this mutation can do. And then I can actually write awesome GraphQL queries where I say, okay, I want to actually select the errors here. If this is an unknown asset error, I want to know what the invalid symbols are that I provided. Or if it's the wrong user, then don't tell me what user I should use, just say it's an error. But maybe I want to have a code here that tells me what kind of error it was in any case. So I can run that here, and in this instance, I'm not authenticated. So let's quickly sign in. And in my backend, anything works. So I just can say whatever. And actually, let's do the second error here. Then I can refresh that. And in this case, I don't get what I want, actually. Okay, my demo crashed. I didn't try that out. But it... Okay, there's something wrong with my DB setup. Okay, let's move on, because I have more. But actually, it would have selected, if it worked with the database there, it would have selected that it was the wrong asset here. It would have shown you that the symbol BTC2 is actually wrong. Okay, let's move on, because I have more to show. Let's have a look at real-time data. And that is actually where GraphQL really also shines and gives you all this interactivity, this reactivity in your UIs. So subscriptions is not about a single request response. It's about streams. It's about streams of events, and also about each event, or when we talk about an event stream, will cause actually an execution of our GraphQL execution engine. And then these events are actually translated into response data. Sounds complex, but let me show you how to build the simplest subscription you can do. Let's get rid of that guy. Demo 5. And let's go. Okay, so again, this is our service, the same service, just a couple of iterations further. And we're going to add now real-timeness to it. So what I have here is, again, the types. And let me first create a subscription that is a bit artificial just to see how it works. So we can have a simple ping pong here. So I'm going to add here a little mutation that triggers something. Let's call it foo mutation, and add to it a little method called just send message. And what we do here is essentially we can invoke that, provide a message, and then we have a pub/sub abstraction in Hot Chocolate called iTopic Event Sender, and we support actually a ton of pub/subs, like you can have RabbitMQ or Nuts or Redis or what have you behind that abstraction. And it's just a NuGet package that you have to add, and then it works. Like in this instance, I added here an in-memory pub/sub, so not for production, but for our demo. Okay, let me go back. Okay, so I'm sending now here events, this message, to a topic called message into my event system. And on the subscription side, I can now introduce an onReceive message, and that is the thing that I could subscribe to from the client side. I told here my subscription resolver that it's subscribed to the topic event stream, and I get here the event message. And then in this case, I just return it. Let's just run that. Oh, it should already run. And let me go up here. So we can now write here the mutation. And in this case, let's refresh my schema and say send. Come on. Oh, no, it's wrong. Shouldn't be wrong. Is it wrong? Again. Refresh. Okay. Let me quickly fix that. Let's see. Program, helper services. Because at the moment I cannot see what I'm doing because we are having a lot of events in my backend here. So what I'm going to do is to switch off this event processor here, and then we can just watch that again. And refresh. That seems all right. Yeah, unavailable schema, but it should actually tell me why. Okay, so this would work. But I have a hosted version to show you just how this would work. So this is actually everything I have to do. Let me show you one more thing here, and then I show you the thing I have as a backup. I'm getting rid of that. It's always a real-time demo that I mess up, but okay. So the second thing here is, and let me go to my slide quickly. This is the spec components that we have in a subscription. So we have an event stream and a response stream. In our application, we have these price updates. So I'm not sending in a mutation, actually. I want to subscribe to a real-life backend somehow, right? So we have two components here, actually. And that is the onReceive. No, not the onReceive. The onPriceChange resolver that I have. This guy here. And it will get a trigger for symbols that have a price update, and then use a DataLoader here to load that price update. And then there is a second component, and that's our event stream. So I can create here an event stream, and an event stream for us is just an IAsync enumerable that yields events back. And I can actually tell my subscription here to subscribe with this stream. So use this stream method whenever a user subscribes to create a stream, and then listen to it. And behind that stream could be anything that you have in your infrastructure. You don't even have to use our abstraction here. Let's just quickly see if that works. Otherwise, I use the thing I have prepared. No. One more try, because it would be cool. Create new document. Oh yeah, okay, so something in my client state was messed up. It seems to be, so it works. So I'm doing here a subscription. And in this case, I'm using the onPrice change event here. And I'm subscribing here to the symbol, and then to the latest price that we get. And now I have to change one more thing here, because I disabled our real-time events. Quickly go in here, fix that, and hope it. Okay, it comes up. You can see all the events are actually happening here, and we subscribe to it, and you can see real time my query coming in. And the coolest thing here is, from a client perspective, the user that uses your GraphQL endpoint, it's just a change of keyword. And this is at the moment running over sockets, but I also could say, because we implement a lot of these GraphQL, I also could say I want it over essentially an HTTP post call. And then it works the same. You can see new stuff coming in. Okay. So there is one more thing. And let me go for that to this guy here. Let's refresh that. Go away. Go back to the slides. I cannot skip the animation, so we have to wait through it. Okay. So there's one more aspect, and that is a feature we are in the spec working group are having the most focus at the moment on. It's called defer and stream. And this feature allows the consumer of the API to mark sections of the graph that we want to defer or deprioritize. Let's say, for instance, the REST data that we get from REST is actually slow. It is slow. So this piece of query we know is slow. How can we deal with that? So with defer and stream, we suddenly have a tool to say this section deferred. I need the name immediately, and then send me the rest whenever you're finished. We can do that with defer, or we can also stream lists. And what we are doing in the execution engine is essentially breaking up the request graph into two awaitables, promises. We first focus on the initial payloads and then send you the subsequent payloads. Let me show you how that actually works. And the use case, for instance, if you are here on the main page, then it's all the data that we fetch here in one go. But look at this. I can scroll to the side. There are more graphs. When I initially open this page, the user doesn't see this. And the moment he sees the content and swipes to the side, it will already be there. But it doesn't have to be there from the first millisecond on. So what we can do is change our request here. This is my request at the moment. It takes around a second, you can see, or 2 seconds on this Wi-Fi. But now I can optimize. I could say, actually stream this. I need the first item immediately. And also this section, I know it's quite expensive, so defer that. And then run that. And you can see 210 milliseconds for the first data to arrive. So I can render my page with all the data I need. And what is happening here is that we are patching data. So I get the Bitcoin price here first, and it's actually 10 patches. And then at some point I get graph data here, and my client patches that, and it looks as if the site is super speedy and it's super fast. Actually, it still takes 2 seconds for all the data to arrive, but we now spread it out and can already render. Okay, let me get to that. So there was a nice bachelor project at the, I cannot even read it, but at the university in Sweden that looked at the speed of GraphQL and REST and the GraphQL implementation as a whole in the .NET ecosystem. They found out, okay, I spare you the abstract, that Hot Chocolate is not only the fastest GraphQL server in the .NET ecosystem, but it's also faster than a REST API. So how can that be? Because with GraphQL, when you specify your GraphQL request, you create the most optimized GraphQL, the most optimized REST service ever. Because you saw when I showed you the structure, actually GraphQL request is like a method. So you create like stored procedures for a REST service, you could say. And at the end, when you deploy your GraphQL server, you have the most optimized REST communication, because it's just everything HTTP post, even the streaming data. It's just simple HTTP post request that works over HTTP 1.1. So you get the most optimized API ever. That's why we can compete with all the other platforms. The second thing here, so this is actually, this work was done on Hot Chocolate 12. It took 81 lines of code to create the example, 79 lines of code with the minimal API. With Hot Chocolate 13, the new version, you need actually 4 lines less now. So the code that you have to write is even less than with the minimal API now. So conclusion. So GraphQL is evolving rapidly. There are new features like defer and stream. There are other things coming out. And it gives you all the tools to finally get rid of these endless cycles between front-end and back-end engineers. So you can suddenly move on both sides without stopping the other. And GraphQL is like, if you look at other platforms, Java, JavaScript, or it's rapidly evolving and has rapid adoption. Microsoft will show, I think, at Build a lot of GraphQL products. So there's a lot coming also now from the Microsoft side. And if you look like tools like Teams or so, they are running on GraphQL. GitHub is running on GraphQL. Netflix, New York Times, Airbnb, all GraphQL. Even Twitter is running on GraphQL. So if you look at the biggest companies, they are all running on this technology today. LinkedIn is, by the way, also running on GraphQL. Okay, with this, all I showed you is open source, it's free. So you can get to our GitHub repository, fork it, play with it, connect with us, and star us if you want. And with that, I'm done. If anybody has questions, I'm open to that. Same as with REST. It's HTTP post, so it's the same authentication. Authorization depends, but it's the same that you do with REST. You have to, either you have a new application layer or you annotate it. We have the same annotations that you would do in REST. You can just put them on the GraphQL specific stuff. And then we also use the same policy engine by default. But we also support OPA, the Open Policy Agent. So if you want to use a different policy system, you can also plug it in.
When working with REST APIs and we work with some kind of integration test, we usually work with the output application factory. Do we have any easy way to create a client for doing integration tests through GraphQL?
Yes. So we have like a testing framework. We also have like a client that's called Strawberry Shake for .NET. And like if you're looking for the JavaScript ecosystem, there are tons of clients. But yeah, we also have a client called Strawberry Shake. And there you write these fragments or write these queries, and we compile you the client to that.